Welcome to this predicted paper. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by clicking the link. Our website is full of free content to help you with your exams. You can even save your scores with a free account. Enjoy! Mr. Thompson asked the students in his maths class which animal they would most like to have from the choices dog, cat, rabbit and parrot. Their answers are shown below. Complete the tally and frequency columns on the frequency table for the data. For this we're going to cross them off as we go. So we're going to start with cat, and then another cat, and then a dog. And I'm just going to skip a few now until we get to this point. Now the next one is a cat. And you can see we've got 4 on our tally. Now, whenever we get to 5, which we have here, we put a little gate through it. And so we have the same with dog. Now, for the next dog, we just start a new set of tallies. And then rabbit. Finally, we need to do our frequency column. Now, frequency just means how many. So for rabbit, it would be 2, and for parrot, it would be 3. Now for dog and cat we need to add the 5 on, so it's 5 plus 3 which will be 8 for dog, and 5 plus 2 which will be 7. It's always a good idea to add the frequencies up and check it adds up to the same as the list we have. So both of them add up to 20, so we know it's probably correct. Find the number of students in Mr. Thompson's maths class. Every student gave a response, so each of these is an individual student, and altogether there are 20 students. Compare the amount of students who chose dog with the amount who chose parrot. When asked to compare, we're going to be using words like more or less. Now we know that there were 8 dogs, and we know that there were 3 parrots, and you can count them in here, so dog 1, 2, etc., and parrot 1, 2, 3. So our sentence is going to say that more students selected dog than parrot. Mr. Thompson finds the mode from the data. Give a reason why the mode is an appropriate average to use in this situation. Something that you'll notice about the data that we have here is they're all words, and the only average that can work with words is the mode. So the data is not numeric, as in it's not a number, therefore the mode is appropriate. Give one advantage of displaying this data in a tally chart rather than leaving it as raw data. Looking at the raw data, it's quite difficult to tell which was the most popular and just general analysis. So the reason why we put it into a tally chart is it makes it easier to analyse the data. The table shows the results of a survey into environmental actions and awareness. For example, 60% of all respondents said recycled regularly, but only 41% of 16 to 24-year-olds said this. Some respondents participated in more than one option. A person who selected bought second-hand items is chosen at random. Describe the most likely gender and age of this person. For this question we need to look along the row that says bought second-hand items. Looking at the genders, 84% were female and only 80% were male, so it's more likely that the random person who was selected was going to be female. And looking at the ages, we've got 72, 82, 85 and 89% which were 18 to 26. So the person who was selected randomly was most likely to be female and 18 to 26. Describe the relationship in the data between joining a cleanup event and age. Let's look at the row that says joining a cleanup event. And let's look at the ages. So at 18 to 26, it's only 5%. 27 to 36 is now growing to 8%. 37 to 56 is growing to 9%. And then 57 plus is 14%. So the proportion of people joining a cleanup event increases with age. Olivia is starting a second-hand shop. She suspects that over half of her customers will be female. Explain how she used the information from the table to come to this conclusion. Olivia is starting a second-hand shop, so the environmental action she's most likely interested in is people who bought second-hand items. Of these people, 84% of them were female and only 80% were male, so over half of them were female. So we can say that the percentage of females who bought second-hand items was 84%, but the percentage of males was lower at 80%. The population pyramid below shows the percentage of males and females in each age group for the town of Brackenford. Write down the percentage of females in the age group 50 to 59. The age group 50 to 59 is here, and we can see that the females are on the right hand side. So we're looking for our answer of 4.2%. Find the age group for males that has 6.7% of the population. Looking down the left hand side of the population pyramid, we can see that 6.7 is here, which is the ages 30 to 39. So our answer is 30 to 39. Find the age group that has 14.8% of the population. A trick we can do with this is we can halve that 14.8, and it gives us a rough estimate of roughly what we're looking at when we look at the population pyramid. So we're looking for numbers that are roughly 7.4. Now these two are both beneath 7.4, so we need to be higher than those. These two are both above 7.4, so we need to be lower than those. And you can see here that 7.2 and 7.6, both of those are roughly 7.4. If we add them together, we get 14.8. So the age is 20 to 29. Compare the percentage of the population aged 30 to 59 between males and females. Looking at the population pyramid, we're looking from 30 to 59. So these three parts here. Let's start with the males. Let's add 3.7, 5.2 and 6.7, and that will give us 15.6%. Now let's look at the females. 4.2 plus 5.4 plus 6, and this also gives us 15.6%. So our answer will be that they are both the same. Give a reason why the sum of all the percentages is 99.8% and not 100%. For this question, it's not necessary to go and add up all the percentages, but looking at the numbers themselves, they're all to one decimal place, so chances are they've all been rounded. And if they've all been rounded, then they won't add up to 100%, because some of them will be rounded down, some of them will be rounded up, and it looks like more of them have been rounded down than up, which is why they add up to 99.8%. So our answer is that they've all been rounded. A cinema sells 4 different ticket types at different prices. The tickets for a weekend have been recorded in this table. The owner of the cinema wants to open up a new cinema in a different city. She uses the data to predict how the tickets will sell in the new location. The owner wants to improve her predictions. Explain how she can do this. The simplest way to improve your predictions is to collect more data. The owner opens up the new cinema. The table below shows the ticket sales over the opening weekend at the new cinema. Compare the sales of £10 tickets at the new location compared to the original location and suggest a reason for any difference. At the old location, the £10 tickets were 15% of sales, but at the new location they were 35% of sales. So there was a higher proportion of £10 tickets at the new location. There are many potential reasons for this difference, but the one I've suggested is that this could have been because at opening weekend, people may be happier to spend more on a ticket. Marco owns a food truck that sells pizza. Customers can choose either cheese or pepperoni pizza and either a cola or a lemonade drink. He records his sales in a two-way table, but the table is incomplete. Complete the two-way table. Let's start by looking at the cheese row. So there's a total of 80 and there's 35 lemonade. So 80 take away 35 is 45. Let's look at the pepperoni row. And we've got 48 cola, 47 lemonade. So we're going to add the two together to get the total, which is 95. And finally, we can look down on the lemonade column. And we've got 35 cheese pizza, 47 pepperoni pizza, so together that's going to be 82. Now we can check these by adding up the 80 and the 95, and that adds up to 175, and the 93 and the 82, which also adds up to 175. Find the probability a customer chosen at random ordered a cheese pizza, ordered a pepperoni pizza and a cola, and did not order a cola. Let's start with the probability they ordered a cheese pizza. So in total, 80 people ordered a cheese pizza, and there was 175 people who ordered altogether. So our answer is going to be 80 over 175 for part 1. Next, let's look at part 2. Ordered a pepperoni pizza and a cola. So cola and pepperoni pizza is here, so that's 48. And again, there's 175 altogether. So it's going to be 48 over 175. Finally, we're looking at did not order a cola. Now, did not order a cola is exactly the same as saying ordered a lemonade. And there were 82 that ordered a lemonade. So it's going to be 82 over 175. So 82 over 175. Marco is ordering drinks for the following month. Explain with a reason if Marco should order more bottles of cola than lemonade. Looking at the table, Marco sold 93 colas and 82 lemonades. So yes, Marco should buy more bottles of cola than lemonade because he sold more cola than lemonade. A school is considering introducing a new lunch menu. Daniel is going to conduct a survey to gather opinions from everyone in the school. Daniel thinks that he should take a sample rather than a census. Give 2 reasons why Daniel might think this. A census would require Daniel asking everyone, yet with a sample he only needs to ask a few people, so it will be cheaper and it will be quicker. Daniel has decided to use the class registers as a sampling frame. Explain what a sampling frame is. A sampling frame is a list of all the members in the population. Daniel has decided to use the class registers as a sampling frame. State one problem Daniel may have using the class registers as a sampling frame. Try and think of a member of the population that will not be on the class registers. Of course, the staff. So the problem is that the staff will not be included. Give 2 reasons why Daniel should conduct a pilot study. A pilot study is a much smaller scale survey, so he can ask a few people just to check whether the survey has any issues, and also to give an indication of what the results may be. Sophia is an NHS trust manager investigating the working hours of junior doctors. She takes a simple random sample of 12 doctors in a hospital and asks them to report the number of hours they worked last week. The working hours of the 8 people are listed as 36, 41, 39, 70, 40, 38, 42 and 38. Sophia believes that one of the values is an outlier. Describe the meaning of the term simple random sample. A simple random sample is a sampling method where every individual in the population has an equal chance of being selected. Write down the value that is most likely to be an outlier and explain why you think this value is an outlier. Looking at the numbers, all the numbers are roughly 40. We've got 36, we've got 38, 41, 42, but there's one number that is vastly not near 40, and that's 70. So the outlier is 70, and the reason is that it's significantly higher than the other numbers. Sophia removes the outlier. State whether the mean of the remaining 7 values is greater than, is equal to, or is less than the mean of all 8 salaries. Give a reason for your answer. The mean is going to be less because the value that Sophia removed is higher than all the other values, therefore the mean will decrease. After calculating the mean of the 7 values without the outlier, Sophia uses this mean in a report to describe all the doctors in the NHS. Describe 2 things that could affect the reliability of her conclusions. Sophia only asked 8 people, and we're only using data from 7, so there's a small sample size which will affect the reliability. Also, Sophia removed the outlier, and that's normally okay, but it could be that removing the outlier may ignore the true variation in working hours. The accurately drawn pie chart shows information about how people in the UK rated their health in 2021. Explain how you can tell that most people viewed themselves as very good health in the UK in 2021 using the pie chart. If we look at the pie chart, very good health is this shade here, so it's this one here, and it definitely has the largest sector, so very good health has the largest sector. The population in the UK in 2021 was estimated to be 67 million. Calculate an estimate for the number of people in the UK in 2021 who rate themselves as having good health. Round your answer to the nearest million. Good health is shown by this shade here, and we just need to get a protractor out and measure the angle of the good health, which is 122 degrees. Next, we need to work out what fraction of the full circle that is. So it's going to be 122 degrees over 360 degrees because there are 360 degrees in a circle. Finally, we need to multiply that by 67 because we know that the population is 67 million. So it's going to be times 67. Now our answer will be whatever million, so we don't need to write 67 million, we can just do 67. And when we do that, we get 22.70555, and to the nearest million, that will be 23 million. Sophie recorded the heights of male and female students in a school. Both groups were measured using the same method. The box plot shows information about the heights for the male students. The table gives information about the heights for the female students. Draw a box plot for the heights for the female students. The female students' heights are given to us in the table, and the least tall was 150. So on our graph here, I'm going to draw a line at 150. Then the lower quartile was 158. And we can see here that each of the little squares is going to be 2. Then the median is 162, so we'll make sure that goes there. Then 172 is going to be there. And then 190 is the most tall. Now we need to join these up properly. So we have our little whiskers here, and then we've got the box here. Make sure I get this right. There we go. Compare the two distributions of heights. Give 3 comparisons and interpret one of these comparisons. We're going to start by comparing the medians. Now the medians for the males was 170 and for the females it's 162. So in the comparison we're just going to write the median heights for the male students is greater than the female students. Next we're going to compare the interquartile ranges. So the interquartile range for the males was 178 take away 162, so that's 16, and for the females it's 172 take away 158, so that's 14. So we're going to say that the interquartile range for the height of the male students is greater than the female students. Next we're going to look at the skew. So looking at the male box plot, it looks pretty symmetrical. Now for a previous question we did the box plot for the females, so I'm just going to show that now. And you can see that the skew for the females is positive, because if you look at this gap here and compare it to this gap here, and same with the distance between the median and the upper quartile compared to the distance between the median and the lower quartile, it's definitely a positive skew. So if we go down, then we can say that the skew for the heights of the male students is symmetrical and the skew for the female students is positive. Finally, we're asked to interpret one of the comparisons. I'm going to interpret the median heights being bigger for the male students and say that the male students are on average taller than the female students. Liam gathered data on 11 movies, recording their production budget in millions of dollars and total box office revenue in hundreds of millions of dollars. He represented his findings in the scatter diagram below. Draw a line of best fit on the scatter diagram. When drawing a line of best fit, there's a couple of rules. The first one is the line must go with the data, so if you draw a line down like that, that's not going to be good. And the second one is that there needs to be roughly the same amount of points above and below the line. So if I draw my line of best fit in like this, and what you can do is you can just rest the ruler on top of the page until you're ready to draw a line of best fit. Now, if you haven't got it absolutely perfect, it's a little bit too high or a little bit too low, don't rub out and start again. There's quite a big tolerance for the line of best fit. For instance, on this one, it could probably be a little bit higher. Describe and interpret the type of correlation shown by the scatter diagram. When asked to describe a correlation, you're looking to see whether it's positive, negative, or there's no correlation, and whether it's strong or weak. Looking at R1 here, it's going up, so it's going to be positive. And if you look, all the points are close to a line of best fit that we can draw, so it's going to be strong. Now, when asked to interpret, we need to relate that to the question. So we say, as the budget increases, the revenue increases. A new movie will be releasing soon with a budget of $250 million. Liam is planning on using the line of best fit on the scatter diagram to predict the revenue of the movie. Explain whether or not it is appropriate to use the line of best fit for this prediction. If we draw on our line of best fit to the scatter diagram and have a look at where we think roughly 250 is, I think about there, so $250 million. I mean, you could see that we could use it to predict and then draw a line across and then work out what this number here is. But you can see that the value is vastly outside of the range of the data that we have. So our answer will be that it's not appropriate because this would be extrapolation, which is where you are using your line of best fit outside of the range of the data. Sophia investigates the heights of 210 students in a school. The heights range from 129 centimetres to 203 centimetres. Sophia considers using one of the two possible group frequency tables for the results, Table A or Table B shown below. Give two advantages of using groups data rather than raw data. Group data makes it easier to process large amounts of data, and it can make it easier to compare different groups. Sophia feels that Table B gives more detail than Table A about the results. Assess the appropriateness of Sophia's claim. Looking at Table A, there are no frequency for 90 to 120 or 210 to 240, so all the data is sort of squeezed into the 120 to 210 range. But looking at Table B, there are 13 in the first group, 62 in the second, 109, 24, and then 2 in the last one. So the data is more spread out. So in Table A, there are no students in 2 of the groups, so these groups are not needed. In Table B, each group has a smaller class width, showing more detail. So Sophia's claim is justified. Make sure to always write the conclusion. Sophia wants to work out the average height of the 200 students in the school. She decides to use Table B. Calculate the average height of the 200 students in the school, giving your answer to 1 decimal place. To find the mean, we need to add up all the numbers and divide by the amount of numbers. But the problem is we don't know what the actual raw data was. So what we need to do is, first of all, change all of the heights here to their midpoint, so that to work out the mean, we need to first of all add up all the numbers and divide them by the amount of numbers. Now the problem is we don't have any of the raw data here. For instance, we know that there are 13 heights between 120 and 140, but we don't know what they are. So the first thing we need to do is work out the midpoints for each group. So instead of putting them as sort of a big question mark, we could say that all of those ones in the first group were 130. Because that's the midpoint of 120 and 140. If you don't know how to find a midpoint, what you can do is you could add the two numbers together, the lower number and the upper number in the group. So 200 plus 220 is 420, and then divide by 2, which is 210. Now, we have assumed that all of the numbers in the first group were 130, but we've got 13 of them, so we need to add up all 13 of those. So we can just multiply the 13 by 130, which will give us 1,690. And we can do this for each of the groups. So now we know each of the groups, what they add up to. We need to find out what the total add up to. Remember, the mean is adding them all together. So we need to find the sum of fx, which will just be adding up this column here. For the mean, we'll need to divide that by the amount of numbers. Now, the amount of numbers is shown with this frequency column here, so we need to add all those together. And then to find the mean, we just need to do the 34,500 divided by 210. The question asks us to give our answer to one decimal place, so our answer will be 164.3. The Venn diagram shows information about 30 books published in 2020. A is the event that the book was written by a British author. B is the event that the book was a bestseller, as in sold more than 100,000 copies. The numbers in the Venn diagram indicate the numbers of books. In the Venn diagram, explain what the number 10 means. The 10 is in the overlap of A and B. So it will be the number of books written by a British author and were a bestseller. Explain whether or not A and B are independent events by finding the probability of B and the probability of B given A. To find the probability of B, we're going to start by finding out how many of these books were in B. So we've got 10 and we've got 5, so that would be 15. And then we're going to put that over the total amount of books. Now we're told in the question there are 30 books. 15 over 30 is going to be the same as a half. To find the probability of B given A, we need to learn the formula, know the formula, that that's equal to the probability of A and B over the probability of A. Now, probability of A and B is just this middle number here, so it's going to be the 10 over the total amount, which is 30. The probability of A is the 10 and the 8, so that's going to be 18 over 30. There's a lot of fractions there, but the 30s here will just cancel each other out, so it's just going to be the same as 10 over 8, or that's going to be 5 over 9. So the probability of B given A is 5 over 9. The question asks whether A and B are independent events. So we'll need to write a conclusion to this, that A and B are not independent because the probability of B does not equal the probability of B given A, and they would need to be equal if A and B were independent. It is estimated that 2% of a certain type of medical test gives a false positive result. The remaining tests provide accurate results. David took 2 such tests. He does not know if each test result is a false positive or accurate. Complete the probability tree diagram. Each of the false positives will be 0.02, so we can put that onto the tree diagram, and each probability have to add up to 1. So if the chance of a false positive is 0.02, take that away from 1 and you get 0.98. So each of the probabilities of an accurate result is 0.98. Find the probability that both of David's test results are accurate. With a tree diagram, we always start here, and if both of the tests are accurate, we're going to go down here, and then we're going to go down here. And all of the probabilities we collect along the way, what we're going to do is multiply them together. Because in probability, the word and it's accurate and accurate means times. 0.98 times 0.98 is 0.9604. David states that the probability that exactly one of the tests is false positive is less than 4%. Find out whether or not David is correct. Looking at the tree diagram, if the first test is a false positive, the second would need to be accurate for us to have exactly one false positive. Looking along, it would be 0.02 times the 0.98, which will give us 0.0196. If the first test was accurate though, The second test would have to be a false positive to again give us that one false positive. But this is going to be 0.98 times 0.012 again. So this is also going to be 0.0196. Now with tree diagrams, if you've got two answers here and here, and you want to find the total probability, it's either going to be this one or this one. The word or means add. So what we're going to do is we're going to do 0.0196 add the other 0.0196, or just times it by 2. That will give us 0.0392. Now looking at what he is saying, he's saying that it's going to be less than 4%. So we need to convert this into a percentage. And we can do that by multiplying it by 100. So it will give us 3.92%, which is indeed less than 4%. And finally, we just need to write down what we found. So the probability of exactly one false positive is 3.92%. So David is correct because this is less than 4. Always make sure you say either that the person is correct or that they're wrong. The cumulative frequency step polygon shows information about the number of books borrowed from a local library over 70 days. Give a reason why a cumulative frequency step polygon has been used to display this data. A cumulative frequency step polygon is perfect for this situation because the number of books borrowed is discrete, meaning that you can't get 1.5 books. You either get 0, 1, 2, 3, etc. Find the number of days where there were exactly 2 books borrowed, more than 2 books borrowed. If we look at the cumulative frequency step polygon for 2 books borrowed, notice that it doesn't go up at all. Therefore, for exactly 2 books borrowed, it's going to be 0. For more than 2 books borrowed, we can draw a line across from where we're currently at 2, and it's going to be all of these here. And so it goes up to 70 and we're at 25. So the distance here is going to be 70 take away 25, which is 45. So the more than 2 books borrowed is going to be 45. In 30 days, fewer than X books were borrowed. Find the value of X. We can draw a line across from 30 and we can see that all of the jumps up to the line are under 4. So our answer is going to be 4. Laura believes that the interquartile range of the number of books borrowed is 8. Explain why the interquartile range for this data cannot be 8. Looking at our cumulative frequency step polygon, the first time this graph goes up is at 0 and the last time it goes up is at 6. So the range will be 6 take away 0, which is 6. The interquartile range must be less than the range. So our answer is that the range is 6, so the interquartile range must be less than 6. You can complete a unique version of this paper by clicking the link. Our website is full of free content to help you with your exams. You can even save your scores with a free account. Enjoy!